Hey, it's Mr. H from my basement office here at home during a little break here. Again, I would like to thank those of you who have reached out to me during this time. We appreciate that. But today my goal is to help out with some stuff that you have been and will be working on here to try and make this as smooth to us getting some things back to normal here next week. So without further delay, here we go. So you just got done this week dealing with some stuff with inverses, okay? I do want to simplify a couple of things that I think I made mention of in the video, but things are kind of a blur right now. Rules are the same. Switch x and y, f of x. If you want to literally go in here when you're doing these and be like, okay, that's driving me crazy, and Hardy, that you switch these variables also drives me crazy. So the f of whatever, f of n g of x is just going to become y equals, because that's what it is. I know I mentioned that part. And then we're just going to turn the variable on the other side into x if it's not, just so we're always dealing with x and y. Make this a little bit easier. Once we get there, and this is going to be a weird one right off the bat, probably something I wouldn't do to you on a quiz or something like that, would be we're going to switch x and y. So we're literally just going to rewrite this, and the x and the y is going to get switched around. Once we do that, the goal is to solve for y. And some of you are in a panic at this point going, OMG, what in the heck am I supposed to do here? We'll get back to a normal one in a minute, but I didn't think it would hurt to show you this at least. What's the opposite of cubed rooting something? Well, whenever you take a root of anything, so like if you had, the square root of x and then you squared it, we talked about the squared and the square root cancel, right? You're just left with the stuff underneath. This is the same idea. This is a cubed root. How do you undo a cubed root? You cube both sides. So those cancel out. Just leaving me with the stuff underneath, the y equals 2. And the other side, because again, whatever we do to one side, we got to do to both, would be x cubed. And now I got one job left. And that job is to get y by itself. How do I do that? I undo the plus 2, which is minus 2. And I'm done. Now, like I said, the odds of me throwing like that, maybe an extra credit question, but on the normal front, probably not as much, okay? I'm much more likely to show you something like number 3, which is the other one of these that I'm going to do in this particular section. A little more normal, right? Whatever normal is about math, right? So again, we're just going to change these into y and x so we don't get confused. So we're always doing the same thing. You can do this on quizzes. You can do this in the homework. That's a-okay. And again, switch the x and y. It doesn't mean take the whole term with you. Literally just swap them out. And then it becomes a game of how do I get y by itself? So I need the plus 20 out of there. So we do the opposite. Again, this doesn't become negative 20x. I'm not multiplying them. And as I mentioned back in the lesson before, at this point, my last step to get y alone would be to do the opposite of multiply by negative 4, which is to divide. Now, if all you're being asked is to find the inverse, like you are here, I have no problem with you just leaving it like this. However, to give you a little preview into the next section we're going to be looking at, if you're asked that you're going to need to graph this, I would suggest separating the pieces here. So basically what I'm going to do is I'm going to have the 1 over negative 4x, and then negative divided by negative would be plus 5. Either of these, okay, are perfectly reasonable ways to write your answer. On a quiz, they'd both be, marked as correct. But for a graphing purpose, I would try to go this way. We're going to talk a little bit more about that way in a second. So your job would be to try out number 2, number 4, to kind of see what's going on with those. Okay, and again, these are things that once I'm back that we're going to deal with on Monday, trying to get a little bit further with those. All right, let's flip over here. So find the inverse of the function, then graph the function and its inverse. Okay, so first job first. It's just y. That's already x, so I'm not going to rewrite that part. So job 1, we're going to find the inverse. So x equals 5y minus 15. What's our job? Get that y term alone. Do the opposite. And here's where I would do it a little bit differently, and that's a 1. That marking's making it look like 7. It's not. If I'm going to have to graph this, instead of just making this one big fraction when I divide by 5, what I'm going to do instead is I'm going to look at each of these pieces separately. So here's how we would do this. I'd forget about the 15 for a minute. I'd be like, okay, so 1x over 5 would be 1/5 x. And then 15 divided by 5 is 3. There's my inverse. And just to make it a little easier to see on our graph here, I'm going to use pink for the other one. Now, here's something, again, we always run into twists, right? It always seems that way. Like, if I go to graph my inverse first, there's my y-intercept, okay? That first point, we always want to try to make it on here. That's going to make my life easier most of the time. So I'd put my point on the 3. And then again, we've got our rise over run, which here would be up 1 and right 5. Go up 1, 1, 2, 3, 4, 5. We can graph with 2 points. It's better if we do 3 just to make sure if we made a mistake on one of the first 2, it gets exposed. So if I run out of room like I did here, we can do opposites of both of these. So we could do down 1 and left 5 and end up in the same area, on the same line. Down 1 and 1, 2, 3. Okay, and get my 3 points. Now, if you happen to run into a panic at some point, or you're sitting there, you're going, I can't remember if that's the up and over, if that's the y, or any of those things, you do have the option, okay, to get some help. I am using Calculate 84 on my phone. So this is where this one looks more like when you have a situation like I do here at home. I don't have a graphing calculator here at home. I should really change that. But I would go ahead and I would hit y equals. I'm apologizing for some of the glare, but I can't really do a whole lot about it, so I'm going to do the best I can here. And whenever I go to type a fraction in on these, I'm going to need to use parentheses. This is not working how I want. I have an idea. I'm going to pause you all for a second here. Sorry for the pause there. I decided to put my phone into dark mode to see if that helped. It's helping a little bit. We'll see how this goes. So 1/5 x, then plus 3. And so what I can do then is I can hit and bring my chart up, and basically I'd be trying to find the whole numbers. So I see like 0, 3 here, so there's that point. And if I went a little further down, I'd see 5, 4, there's that point. Or if I decided I was going to go up a little bit looking for another one, I'd see -5, 2. So you can use the chart to help you plot some of your points, especially if you run into a situation like we're about to run into. So if I go back to y equals and I clear that out, and I'm looking at this one and I'm like, wait a minute. Hardy, the y-intercept's -15. My screen doesn't even go to 15. So how would I graph this? This is how I would do it, like what we just did there. I would grab these and I would go looking for points that actually fit on my graph. So like here, so 2, -5, I'm going to sneak that off the screen here for just a minute. And if I keep going, I see 3, 0, and I see 4, 5. There's my 3 points. I can graph those. Okay? I've got one more trick for you that I haven't said before. Now, if you're like, I'm good, Hardy, I am good with this, fast forward what I'm about to say so you don't, go, no, I don't need more things to get confused, but it really can make life simple. Let's say one of your graphs does fit, like this one did, okay? Here's what you can do. You can sit with those points, and you can say, okay, so this is like at -5, 2, and this point was at 0, 3, and this point was at 5, 4. Check this out. Without going to the calculator or anything else, I can get the other 3 points for my inverse. Ready? What does inverse mean? It means switching x and y, right? So if I have one of my lines graphed, if I just switch the x and y values, literally just switch the order around, you're like, okay, so what? Check out the pink line. 2, -5, 3, 0, 4, 5. You use your one line to make the other one. You just switch all the x and y values around. It keeps you from the calculator and the technology and having to do all that other stuff. Okay? So now, oh, I did an even for you. What an awesome guy. Okay, so I'm going to do number 7 too, since I've now remembered what an odd is and not an even. I would suggest then you do 8 and 9 instead of just doing the one even to get some practice here. So you're like, wait, let's get our inverse done, and let's try the Hardy graphing trick again on this one. Okay, so I'm going to do it down here because there's a little more room this time. Switch x and y. Okay, we're solving for y. First problem I see is that fraction. It's got to go. So what's the opposite of dividing by 2? Multiplying by 2. Okay, goal's still the same. We want to get y alone. So we're going to get that 4 out of there. And then our last step is to do the divide by 3. Now, as I've said before, I'm going to say it again because it's true. You could leave it just like that. That's the correct inverse. Okay? If you wanted to get it more in a form of what we would look like doing slope-intercept form. 2 over 3 doesn't reduce. Ooh, 4 over 3 doesn't reduce either. This is yuck. I'm not a big fan of this. Like, I don't even know where to start with dealing with that besides the calculator. So let's look at our other one for a minute. Let's see if we can simplify this. We're always looking for a way to make this easier. You're like, that's a fraction too, Hardy. I'm not real thrilled about this. Okay, let's rewrite this one. We're going to put the x term first. 3 over 2, if you hit 3 over 2 and hit math, enter, you're going to end up back in the same place. Okay, but if we do 4 over 2, that's 2. This, okay, is going to be the easier one to graph because I actually have a normal y-intercept. Now, like I said, if this whole thing of y-intercept and slope is driving you crazy and you want to put it straight into the calculator and use the chart, do it. If some of you are tired of me talking about all these tricks and things, fast forward me to the next section, okay? So I get my y-intercept, rise over run, 3 up, 2 right, because they're both positive. 3 up, 2 right. Or the opposite of right and up, left and down. Excuse me, down and left. You got to keep these right, Hardy. Rise over run. 3 down, 2 left. 3, 1, 2. If you want one extra point, 1, 2, 3, 1, 2. Get that graphed in. You will get those same 4 points if you just type it into y equals. Seriously, not joking you. It would be the same. And at this point, You could type this into your calculator and look for the whole number points, and you'd find them. I'm going to show you that in a minute. Or you can go, ooh, what points do I have here? I got -4, -4. I got -2, -1. I got 0, 2. And I got 2, 5. And you know what I'm going to do. I'm just going to flip them all. And then I'm going to prove that I was right with the calculator. Now this gets scary, because if I did any of these wrong, I'm going to kind of look like I have egg on my face. But I'm feeling pretty confident that I'm in good shape here. Okay, so they share a point. Okay, -1, -2, 2, 0, and 5, 2, right here. All right, let's see if Hardy knows what he's talking about, or if my brain has gone to mush. All right, you're like, do I have to type that in that way? You can type it in the calculator this way if you're more comfortable, to be honest. So, I mean, if you want to do that, we could do 2x minus 4. Notice I'm using parentheses. Do I really have to? Yes, because otherwise the calculator is going to do something else that's funky, and we don't want that happening. So divided by 3. I'm going to look at the graph for a minute. It kind of looks like the dots that I have here. I'm feeling pretty good. So second graph, let's go see if I know what I'm talking about. -4, -4. -1, -2. 2, 0. And 5, 2. Already take a bow. Okay, thank you. Thank you very much. So, calculator gives me the numbers. Me just flipping them, once I find the easier the two equations, is going to get it done for me. Okay? But even if it's that first graph, you're like, I don't know how to graph either of these. Then just type it into here, or your calculator when you're in class, and then just use the whole numbers from the chart. You're always going to get at least 2 or 3 to be able to get that done. We can do this. Okay. State if the functions are inverses. Okay, I think I made a note of this back from when you got done with the other lesson. I am not going to concern myself as much with this, and here's my main reason why. There's a couple of different ways that you can do this. Okay. You can plug one into the other and see if you get x, or you can find the inverse of one and see if it's the inverse of the second. And to be perfectly honest, in the big picture of things, that's not going to do as much for you on anything. So here's what we're going to do. We can get some mathematical frustration out. We're just going to give that the big old X here. Okay, we're going to pick and choose our battles at this point instead of trying to do all the things. Okay, which leads us to, and no, for those of you watching, I have not lost your quizzes. They have not disappeared. I am through a good chunk of them. A couple of the classes I've actually got in there already, but I do not have everything in there as of now. I apologize, because it is always my goal to get things done immediately, but if you've been reading any of my notes, it's been a little cray-cray here. So I'm actually getting a little bit of peace here for a few minutes, so I should be quiet and get these done so I can make sure that I can actually finish. Okay, so I'm going to do one in each of these because we've nailed this over and over, and I don't have my factoring help sheet with me, so you're just going to have to roll with me here. When we're in 4 terms, pair them off every time. I do have sticky notes though. So once we pair them off, if there's 4 terms, we're going to lose one of them. And when we lose the one, okay, goal, largest number that divides into both terms, if there is one. Okay, in this case, I believe that's going to be 4. Yes, it is. And then when we're looking at our variable terms, if all of our terms have variable terms, we take the one with the smallest exponent, which would be the 2 in this case. Once we do that, and I'll do this on the first one, basically all you're doing is dividing this by what you took out. We divide the coefficients, we subtract the exponents. Let's do that again. Take the term in the parentheses, we're dividing it by what we put out here. We divide the coefficients, we subtract the exponents, and 2 minus 2 is 0, which means those go away. So our goal now in looking ahead at the last one is going to be, I need this same set of parentheses to show up when I do this. So let's see if we got this. So I look at this and I'm like, ugh. So maybe I start looking at my multiplication chart, looking to see where 9 and 24 is in the same row or column. Maybe I play with the calculator. Maybe I just look and say, hey, 3 is the biggest number that goes into both. So I take out a 3, and I usually hold off on the sign for just a second, because I'm like, well, 24 divided by 3 is 8, and there is no x. Okay, that's looking good so far. So I think this is going to be plus. Negative 9 divided by 3 is negative 3. Hey, same thing. That's what I want. So when I go to write my answer, copy the greatest common factors on the outside, and then the factor that they have in common is the other part. Okay. I'm going to flip and look ahead here a little to see. Lots of cubes, lots of cubes, lots of cubes, lots of squares, lots of squares. Okay. So I'm going to do a couple of these again, because again, you've seen so much of this with last week's stuff that I really don't think we need to hammer this home a whole lot more. The one thing I want to hammer the home, though, is this. Always look first to see if there's something in common. Number in front, not so much. Variable, yep, we both got variables. We can take an x out. Now, it doesn't seem like much, but that's going to change a lot about this problem. Because if I subtract 1 from my exponents and I look and I'm like, ooh, wait. If I have my help sheet in front of me, I'm going, ooh, 125 is a perfect cube. It's 5, and x, I mean, that's not really anything special, it's just x. But I'm going to use my form that I have for my difference, because it's minus of cubes. So if I'm following that form, if you've located your help sheet at this point, you're going to look, and you're going to be like, okay, so first minus second, I'm just using the sign that I had in my original problem. And now I'm following. And the original form says you square your first term. Then it's plus, that's just what the form is. Multiply your two terms together. And then plus your last term squared. And that's it. But I had to get that first term out to be able to get to the cubes. So when you're seeing these, watch for that. When you're seeing a problem like 18, remember, we're going to do it just like it's x squared. You're like, oh, it's a regular diamond problem. It's just multiply and add. Right. It just means instead of being x as your first term, because x times x is x squared, it'll be x squared, because that's how you get to the fourth. And that's the stuff again. And I barked it, I know, forever, that you've got to practice, you've got to practice, you've got to practice, you've got to practice. Okay, we just did a cube. So I'm going to come down here and I'm going to do one more. Reminders again. Okay. Two terms doesn't always mean it's going to be a cube. Look at the exponent. That's a square. So if it's a square, what do I square to get each piece? Still should do your little side work. But now it's a difference of squares on your chart. Right above the cubes is the squares. This is even easier because it's just first plus second, first minus second. That's it. We're done with that. All right, last one I'm doing. I'm not getting sucked into doing a even again. Oh, that's the one I want. Okay. We're going to do it like it was 3x squared. But you're like, ew, Hardy. Like, they don't have anything in common. Really? Yeah. We'll finish here with a bang. Slide and divide. Here we go. X to the fourth plus 29x squared plus 168. 3 times 56. The slide just means multiply. So, you're either going to go through your multiplication chart looking for 168. Maybe you're going to grab your calculator and you're going to start dividing numbers in. Get out of there. Maybe you're going to go and you're going to start dividing numbers in. And if it goes in nicely, you're like, okay, that's fine, that's great. And once you've done a few, you stop for a minute, you go, okay, so what's my goal here again? Okay, I got the multiply part. I need these two numbers to add up to 29. And you're like, well, those are all too big. They don't add up to 29. Okay, no help so far. And so I just keep going with this. I mean, decimals do me no good, but I'm like, okay, 6 and 28, does that get me to 29? No. Oh, Hardy. 7 and 24. Oh, I'm getting close, though. Notice, like, if you add these up, it's 46, 34, 31. We're close. Oh, we're so close. 8 and 20. Oh, hallelujah. 8 and 21. Okay, we've made it. Remember, it's x squared, not x, because we got to get to x to the fourth. And everything's positive. 8 and 21. Do not pat yourself on the back and go to the next problem yet. Slide and divide. Divide by the 3. If it goes in nice, fantastic. We'll leave it. If it doesn't, if you go math enter and you get the same fraction back, which we do with 8/3, that 3 just tucks back into the front. And we're done. So remember with these, always look for a common factor first. It'll do you well. All right, that is it for this video. There hopefully will be another one coming here shortly with some more things that you will be dealing with on Wednesday's lesson with division. So we'll see you virtually that way then. Otherwise, keep the questions and things coming, and we'll see you next time.